see, it forms white dense fumes of ammonium chloride. That's what we call effervescence. So in your observations done for you, you can see there on the screen. The first one is that you might be required to moisten litmus paper and hold it very close to sample C. Okay, this is Her Majesty Easy Word Science Channel. Nice to know that you're there. Today, I'm going to help you analyze a salt, and the salt that we're analyzing is ammonium carbonate. That is ammonium trioxocarbonate 4, and this salt is unstable. I think this is the only ammonium salt that decomposes on its own at room temperature to liberate ammonia gas. So there are many ways or many approaches you will apply in the analysis. You might take these literary questions that you may have. You may be told that this is a C, and C is an inorganic salt. Carry out the following exercises on C. You write down the conclusion you draw from the results of each test, and you also identify the gas or gases involved from each of the results you did, from each of the tests you carry out. So let's assume I give you this type of question that you should first put you put that's C in a boiling tube and actually warm gently. Then you're supposed to test for any gas that will come out from your processes. And in testing for gases, remember you require something like the glass rod over here. You also need your lime water, and you also need your litmus paper, which is here. So in this analysis, look at the things I actually need. This is my dilute sodium hydroxide, and here is aqueous barium chloride, and over here is dilute HCl. So these are the things necessary for the analysis of ammonium carbonate. So first, we also need dilute HCl and conc HCl to tell you that this particular compound, ammonium carbonate, liberates ammonia even at room temperature without heating. So if you bring this close to HCl, you see that white dense fumes over there. That shows that this is actually an ammonium salt. So, or you can, this is my glass rod dipped in conc HCl. When you hold it this way, so that's the first analysis for ammonium carbonate. Then, for exam purposes, your examiner might ask you in a stepwise reaction to get a sample, because you shouldn't be analyzing everything in this way. I will collect a sample first. So with my spatula, I'll get a sample of this ammonium carbonate. Okay. Yeah. So this enough. This is enough sample. So you might be required to do this now. You might be required to moisten litmus paper and hold it close to the unknown sample or sample C. And remember that when they tell you use litmus paper, nobody tells you to use red or use blue. Whenever you hear use litmus, you use both of them, both red and blue. So let me use red. Remember that if the salt have an effect on red, it means it won't have effect on blue. So what I do here is moisten this. So they'll tell you to hold it over sample C. This is C. Just very close to it. As you have seen now, it means that the solid liberates an ammonia, an alkaline gas actually, because you'll be told to moisten this and hold it over the unknown sample. When you get it closer to the unknown sample, it shows that that particular salt liberates an alkaline gas, not that the salt itself is alkaline. So in your inference, you write specimen C or sample C liberates an alkaline gas. So that's first step. Or you might be required to just add small solid part of C and add dilute HCl. So you might be required to add in a test tube like this, followed by dilute HCl. This is my dilute HCl. You see that reaction? That's what we call effervescent. And since I know that this is acid actually, so what causes effervescence with acid is actually something that contains trioxocarbonate 4. So it confirms that this sample contains trioxocarbonate 4 ion, and by so doing, don't just conclude that it contains carbonate 4, but in your observation you just say, on adding dilute HCl, you say there is effervescence, colorless, odorless gas evolved, which turns lime water milky. You watch one of my videos here in this channel where I show you the test for carbon 4 oxide, and you see how it turns lime water milky. So this effervescent actually, in your observation, you say effervescent occurred. If you are told to add dilute HCl to the solid sample, as we observe, there will be effervescent. Remember, effervescence is the evolution of gas from liquid. So the process of evolution of gas from liquid, as you saw that time, it looks like you opened your drink. As you can see, you see that evolution of gas. That's what we call effervescent. And the gas is colorless, odorless, and it will turn lime water milky. Then, in your inference, you just say that sample C contains CO32 minus. That is trioxocarbonate 4, as you can see, the trioxocarbonate 4 ion, as you can see there on the screen. So in that aspect, we are done with this step. So I take it again. If you are told to add dilute HCl to a small sample of C, I called it C. Remember, what I'm analyzing is ammonium carbonate. So there will be effervescent, a colorless, odorless gas will be liberated, which will turn lime water milky. Then in your inference, you say CO2 gas, because that's the only gas that turns lime water milky, and the only ion that's the anion that liberates carbon 4 oxide on treatment with dilute acid is trioxocarbonate 4 ion, that is CO32 minus. Okay, this is another way. Then the next form that this may take is you might be required to put solid sample of solid sample of about half a spatula of C, sample C, and then add few drops of sodium hydroxide. This is my sodium hydroxide. I will get my glass rod and other things ready for testing. This is my litmus paper. I have to get it moistened. Okay, now I'm ready to carry out the next step. So the experiment I want to do now, this step is where you are asked to add few drops of dilute sodium hydroxide to solid sample or to half spatula of sample C. Remember, sample C is ammonium carbonate. They will tell you to add few dilute sodium hydroxide to sample C, then followed by gentle heating. So this is my sodium hydroxide. Let me use another dry test tube. Okay. Okay. This is even much. Then followed by heating. You might be required to heat, or you might not be required to heat, because here I have my source of heat, and with my test tube holder, I got the test tube here. Okay. Yeah. Okay. Then I'll hold my litmus here on heating. Then you see, then you see there is a choking smell, irritating choking smell, and this is the quality of ammonia gas. That's the only gas that gives this. Remember, why smelling or trying to detect the smell of a gas, you don't take it direct, you waft and eventually get it, because it might be too offensive. So the gas is still coming out. Then I will still use my glass rod dipped in HCl. Take this back to my burner. See, it forms white dense fumes of ammonium chloride. So this is another way of analyzing ammonium carbonate. So let me take it again. The test is to add small sample of C, solid sample of C, and add few drops of dilute sodium hydroxide, followed by warming. Then if you warm it, there will be liberation of a colorless gas with a choking smell or irritating smell, which turns moist red litmus paper blue, as you can see here. And the only alkaline gas we know is ammonia. Therefore, in your inference, what you're supposed to write in your inference is ammonia gas from ammonium ion, because the only salt that will liberate ammonia on treatment with alkalis is ammonium salt. And this is how to test for ammonium salt. When you heat any salt with sodium hydroxide, even potassium hydroxide or calcium hydroxide, if it liberates ammonia, it shows that the salt is an ammonium salt. So what I'm analyzing today, the sample C has proven to contain ammonium ion. Remember, the first tests are carried out with a dilute HCl that liberated colorless, odorless gas, which I told you with line water milky. This shows that the sample C that we're analyzing also contains CO3 2-. Now, this test also confirmed that it contains ammonium ion. Then we might take another way of analyzing ammonium carbonate. So the next one is that you might be required to dissolve a small solid sample in water. You might be asked to dissolve some part of C in water, or dissolve a half spatula of C in about 5 cm³ of distilled water, then add barium chloride followed by excess dilute HCl. So I will still collect my sample C here. Okay. It's much. So I'm dissolving this in water. Do you have any question there? Dilute HCl. Any acid can do that. Dilute HCl, when you add dilute acid to any sample, if you see effervescent, a colorless, odorless gas evolving, turning lime water milky, it shows that that sample actually contains CO3 or HCO3. Now, this is the step. This is the solution of sample C. You will be required to add, I want to use a bigger boiling tube because the reaction the effervescence will be too high. So if you watch well, it is still fuming around. So to stop the fuming, I have to close this dilute, this concentrated HCl. So like I told you, you might be required to add some solid parts of C in a test tube or boiling tube, and then add about 5 ml, dissolve in 5 ml of water, add barium chloride, then followed by excess dilute HCl. So this is my barium chloride, and this is my dilute HCl. So here we move. You add this, just add, but don't add much. Okay, we are there. Now, what do we interpret from this? Anytime you add barium chloride to unknown sample and it forms a white precipitate, it shows the presence of three ions, which are sulfate 6 ion, sulfate 4 ion, and trioxocarbonate 4 ion. That is SO4 2 minus, SO3 2 minus, and the CO3 2 minus. But if you add barium chloride to an unknown sample and there is no formation of white precipitate, it shows that sulfate 6 ion, sulfate 4 ion, or carbonate 4 ion is absent. Remember what I used is barium chloride. So we use this particular reagent to detect the presence of SO4 2 minus, that is sulfate 6 ion, SO3 minus, SO3 2 minus, that is what we call sulfate 4 ion, or trioxocarbonate 4 ion. But if there is no visible reaction on adding this, it means that this particular sample we are analyzing have no SO3, no SO4, no CO3. Then the second thing is this: the three behaves alike with barium chloride, but they don't behave alike with dilute HCl. Let me explain before I carry out this test. If I add this dilute HCl and the precipitate remain, like the precipitate remain as it is now, it shows that what we have is SO4 2 minus. So what does it show? That when you add barium chloride to a known sample, the formation of white powdery precipitates which persist in dilute HCl confirms the presence of sulfate 6 ion. But if I add this acid, dilute acid, if it shows effervescent and eventually the precipitate dissolves, I am suspecting two things: no more SO4, I'm looking at SO3 and the CO3. But the difference now between SO3 and SO3 and CO3 is that the gas liberated are not the same. If it is SO3, SO2 will be liberated, that's sulfur 4 oxide, which have the smell of a burning matches and is choking. But when it is trioxocarbonate 4, that is CO3, the gas that will be liberated is actually carbon 4 oxide, which is colorless and odorless, and it turns lime water milky. So let's go, try your ability and check if you can predict the ion here. I'm adding the excess acid. Okay, you see that's what we call effervescence. So in your observation, what do you observe here? There is effervescent, a colorless, odorless gas evolved. Normally, since we know this is ammonium carbonate, the gas that evolved here will turn lime water milky and the precipitate dissolved. So you can see the precipitate is clear. We are no longer looking at SO4. It means that what we have here is CO3 2 minus. If it is SO3 2 minus, it will release a gas that have the smell of a burning matches. But this one, on wafting, is odorless, and that shows that what we have here is trioxocarbonate 4 ion. Now, let me construct the question for you. You can see there on the screen. The first one is that you might be required to moisten litmus paper and hold it very close to sample C. Our observation is that it turns moist red litmus paper blue, and that shows that sample C liberates an alkaline gas. Don't say that sample C is alkaline, and remember you are not told to touch it. They say just hold it close. So on holding it close, it affected the color of moist red litmus, and anything that changes red litmus to blue is alkaline, and it's obvious that the common alkaline gas we have is ammonia. Then you might also be required to add dilute HCl direct to the solid sample of C, being ammonium carbonate. There will be effervescent, a colorless, odorless gas will be evolved. That's your observation. Then, to confirm the gas, still in your observation, you say the gas turns lime water milky. For your exams, the examiner will not tell you what to be used to confirm your gas. No, the question will just tell you identify any gas or gases evolved. So it is now left for you to be very, very cautious and test for any gas. So some might say there is no lime water in the specimen or what the examiner provided. No, it's left for you to keep them around. When I started, I showed you I have my glass rod, I have my litmus paper. There is also a lime water around, but I don't have the mechanism to bubble it because I've done that video here on this channel. Then you might also be required to add few drops of dilute sodium hydroxide to the solid sample of C and then warm gently. On doing this, still ammonia gas will be liberated. Then another test that we did is to dissolve about half spatula of C in 5 ml of distilled water, then add barium chloride followed by excess dilute HCl. This test can be replaced with, there are two things that pair. If you use barium chloride, you use HCl, but I might decide to use barium nitrate. If I use barium nitrate, I will use excess HNO3. So the two pairs that can work, that can replace this, it is either you are using barium chloride and HCl, or you are using barium nitrate and HNO3. all of them show similar results. What we got here is that on adding barium chloride, there was a white precipitate. And I told you, if you add barium chloride to any unknown sample, a solution of an unknown sample, the formation of white precipitate indicates the presence of SO4 2-, SO3, CO3 2-. Then on adding excess dilute acid, it will pick the one that is present. It is only SO4 2- and CO3 2-. Sorry, it is only SO3 2- and CO3 2-. That is sulfate 4-ion and triazocarbonate 4-ion that dissolves in excess dilute HCl. So that's the proper test. Remember, in this video I just taught you how to analyze ammonium carbonate. But don't tell the examiner that sample C or sample D, whatever they call it, is ammonium carbonate when you are not told to identify this compound has been analyzed. And I told you that it is the ammonium salt that liberates ammonia gas even without treating with sodium hydroxide. All other ammonium salts, if you treat it with alkalis such as potassium hydroxide, sodium hydroxide, even calcium hydroxide, they will liberate what? Ammonia. So can you now test your ability? How do you confirm ammonium salt in the lab? Answer that question. Another question, how do you confirm the presence of carbon 4 oxide? Then what's the color of ammonia gas? Then what's the smell of ammonia gas? Is it pleasant? Is it choking? Then what's the effect of ammonia gas on moist litmus paper? And also, please, lest I forget, carbon 4 oxide will also have effect on litmus paper, but it will not turn red blue, rather it will turn blue to red, because carbon 4 oxide is an acid anhydride. So in your report, when you treat the sample, when I treated the sample with dilute HCl, it liberated CO2. You can also tell the examiner that the gas turned moist blue litmus paper red. In your inference, the gas is acidic. But the thing that is so specific to CO2 is the ability to turn lime water milky. So that's the only gas that will turn lime water milky. That is it. So thank you for watching. Sir Majesty's World Science channel is good for you. Check out for other videos here on this channel. And don't forget to click the subscription button, share my videos, also like it. Don't act as an opaque object, spread the light. Be transparent. Thank you. Bye for now.
I love you. Thank you for watching.